Sees your eyes.
Oh, that's all I ever get.
All right, beautiful. What do we got?
Well, this is Morgan's CTSV. Morgan is actually the owner of DreamWorks, which is more of a performance-oriented shop. He's based out of North Glen. I do tune for them as well. My scheduled days down there. But he just got this finished up, and I needed a couple days with it to get everything figured out. Doogie fixed the port injection, so he left it here with us to get it dialed in. But it is a 2016 CTSV. Morgan bought it like this, actually from a customer of ours. We fixed the radiator fan and then did a baseline pull on it, and Morgan happened to see it, and the guy ended up selling it to Morgan. So it had quite a bit done to it already when he bought it, but it was stock blower, and now it has the Magnuson 2650. KTEC 112 throttle body, the big Gulp Intake, and then aside from that, other than what Morgan just added, it does have a Weapon X port injection system, which uses a Microsquirt. I do believe it has a built tranny, and then ported heads, and a very, I'm going to say a mild cam. You know, it's all, in my opinion, it's what's the word for it? Like, it's all opinion. You know, it's like, so people are going to hear it chop and think it has a huge cam in it, but it's actually a pretty mild cam for what it is. But it does pull all the way through to 7 so far. So it's running 19 pounds of boost so far. I would say it's a pretty mild tune-up in it. I don't think I would push it any harder just because it's stock bottom end. I'm more afraid of RPM at this point because this blower does pick up boost with RPM, but it's 7,000 anyways. There's not really a need to go much further than that. But other than that, it's pretty stout. So just for reference, with the stock blower, I believe it was just ported blower, the cam and everything, the port injection. The car made 750, and it actually went 10.5 at like 130 something down in Pueblo. I was there for that, and so it moves out pretty good for what it is. It's big, heavy, 4-door sedan. It's got a sub in the back, like a big box. Obviously full interior, no weight reduction. So I'm not going to mention horsepower, just in case Morgan doesn't want to, but I think there's definitely room on the table. We're going to do one more pull just because it's been hot the whole time. We did some pulls back to back to back to back. I do think that we need to change the plugs just because we were fighting the port injection. And I just want to make sure everything's good, but I think it's got a nice, safe, clean tune-up, and I think it'll run high 9, mid 9. I mean, it picked up quite a bit compared to the old blower, and it should definitely pick up the mile an hour. So, I mean, trapped 130 before, and I really think it'll mile an hour in the 140s pretty decent, which is definitely good enough for mid to upper 9s with this big old heavy car. So
Sweet.
very sweet.
So here's a little bit about how this works and what you see in here. So over on this side here, this is the power supply section. So you have your voltage regulator, input capacitors for smoothing everything out. This chip here, this MCP 2551, this is a CAN bus transceiver. So this actually takes the signals from the main processor microcontroller. So that's this here, and then translates those signals into something that's usable on the CAN bus. And then these are the fuel injector driver MOSFETs that we just serviced and worked on. And then down over here, this Max 9926, this is a serial transceiver. So this is what communicates with your laptop when you interface with the Microsquirt module. And then we have various inputs and output drivers and some filtration circuitry and stuff like that. I think this might be a stepper motor driver here. I hadn't looked at the schematics. And what's really cool about this is if you wanted to follow along at home, you can actually look at the schematics for this online because Microsquirt/Megasquirt is an open source ECU. So let's actually take a look at this schematic here and get a better idea of what we're working with. Okay guys, here's our ignition and injection driver circuit. So this side here is in from the microcontroller here on the bottom. This goes to a 1K series resistor. This is kind of like for protection and isolation of the microcontroller. And then we have this 100K pull down resistor, so this pulls this down to ground, right? And so that's our input. And then you could see, as we discussed earlier, our source comes from the ground, and then the drain goes out to the injector. And so because this is a N-channel MOSFET, meaning it switches ground, basically, if you ground the input pin, that prevents this from turning on, and that's why we have this pull-down resistor here in the circuit. And so when 5 volts is put out on this pin, it might even be 3.3, but when a voltage is put out from the microcontroller on this pin, it flows through this resistor, and since this is 1K, which is much lower of a resistance than 100K, the current flowing through this 1K resistor is much greater than what would be pulling down from the 100K, and so that overcomes this grounding here and supplies power to the input on this N-channel MOSFET. And so when this input is high, 5 volts for example, this allows current to conduct between the source and the drain pins, and that's actually what triggers the injector. Now, the eagle-eyed amongst you will notice that this circuit doesn't look complete. There's no flyback diode to arrest the inductive kickback. When the magnetic field in the coil collapses, it's going to send a voltage spike back down this line into this MOSFET. However, so looking at the block diagram for the part that they've chosen for this application, you can see that there's a lot more to it than just a standard MOSFET. So this area of this block diagram is the standard schematic symbol for an N-channel MOSFET. And yeah, there's a body diode in it, but that's not adequate to arrest those inductive kickback voltage spikes that you typically see when driving a coil like a fuel injector. So they have extra features here, and it's kind of nice. You know, there's over temperature protection and a current limiter, and then there is over voltage clamping. But I don't think it's adequate enough in this instance because when you look at the specifications here, the clamp voltage has a maximum of 80 volts. And that's just not right to me because I have seen inductive spikes from fuel injectors well over 100 volts. And so you need a diode that can handle like a couple of hundred or even a few hundred volts is what I would do, like a 1N4004 or something like that. To arrest those spikes that are put out from those fuel injectors. And so what you can do is take a 1N4004 and then put it across like the drain and the 12 volt power rail, and that'll help, you know, arrest that stuff. You could ideally put it like close to the fuel injector. That'd probably be the best way to go. But yeah, definitely a measure of additional protection, in my opinion, is needed to make this part work in this circuit. And that's why we had that failure. Okay guys, so with our ECU repaired, it's basically time to reassemble it and go ahead and throw it back into the car. If you have an ECU that you've had issues with, we do perform ECU repair services here. This includes factory computers and various types of standalone engine management. It's nice to be able to show you on a Megasquirt because, like I said, it is open source, and so like components lists and diagrams are available. And this allows you to not only easily repair them, but more freely modify them to suit your application if desired. And they even supply a pinouts list, like on the silk screen directly. Makes it super easy. And then there's the pinout for the main connector on here as well. This case is pretty waterproof. I wouldn't go and submerge it in something. But if you're mounting this in an engine compartment, Might not hurt to run a bead of silicone, a thin bead of silicone around this enclosure. There is a gasket here on the connector, and so I wouldn't be too worried about that. That seems to seal nice. But this enclosure, I don't imagine is completely waterproof, but definitely should be suitable for most applications. So with this part all done, let's go ahead and throw it back in the car and perform our test. Alright guys, we got our Microsquirt module plugged back into there. So now let's go ahead and perform the test. Alright, so we're going to go ahead and open this. And it shows that our ECU is connected. And so now we go over here to output test mode, injector and spark. We have to enable the test mode. So the second channel was bad, so we set up all of our parameters and hit start. And we can hear the clicking. So we are back in business. I'll go ahead and stop the test. We'll switch it back to injector 1 just to verify. So you can hear it over here. Sweet. So this ECU is repaired. We are ready to finish the tuning on it. And now it's raining, so I'm going to run away now with my camera and laptop. Well, as you can see, we do fast very well here. So next time you have a go fast project of your own, hit us up. How can we help you get to the finish line? See you next time.